So let's take a look at problem 4. It's another acid-base mechanism problem, as we all know. So we're going to take a look at the big picture before we write anything down. We see we have two molecules coming in, acetone and hydronium, being converted into water and the protonated version of acetone. And we see that acetone was neutral before and now it's positive in the reactants, and hydronium was positive before and water is neutral. So we have kind of more than one thing going on. So we see that we probably might need more than one curved arrow to describe the process. Also keep in mind that the positive charge, the net positive one charge, is maintained throughout the entire process. So if you end up with something that doesn't have a net plus one charge, then you've probably done something wrong. So let's start by drawing the Lewis structures. Should be pretty easy because half the work has been done for us. I think we all know what hydronium looks like from general chemistry. So now at this point we want to determine the Lewis base and the Lewis acid, and this one's a little tricky. But what you want to look for is who really has more electrons, I think. And acetone is our winner, basically. The more electrons you have, the more likely you are to attract other positive charges. And since this already has a positive charge, it's really not going to want to bring in another positive charge. And on top of that, think about the hydrogens that are here. These hydrogens aren't very acidic anyway from this compound. It's just a fundamental feature of that compound. So it's going to be very unlikely for this lone pair to attract any more hydrogens. So hydronium is going to be like way more stable when it's converted to water. So here's your Lewis base. That makes this the Lewis acid. Also, you could think about it from the Bronsted-Lowry definition. This is going to be a better proton donor, basically, since this is less acidic than this. And so the way we're going to connect our curved arrows is we're going to take a lone pair from our nucleophile here, our center of negative charge, and connect it to a center of positive charge, one of these hydrogens, because they're basically just protons sitting at the end of these bonds. And so when we take this hydrogen from this ion, the hydronium, we have to do something with the bond that connected it originally. So you basically just move it onto the oxygen, because in the tug of war for these electrons right here, oxygen's definitely going to win, right? Because this bond is already polarized where this has the partial negative charge, and you know that oxygen's way more electronegative. It has way more protons in its nucleus, and those protons aren't very far away from, and the valence electrons aren't that far away from the nucleus anyway. So the electrostatic attraction between this nucleus and the electrons in the bond is like way stronger than the one from this nucleus. It's just one proton fighting all by itself. And so these two arrows are all you need to account for this transformation. So what you get are your products once the mechanism is complete. And I think we all know what water looks like. So now we just have to calculate our formal charges. You'll see this a lot with oxygen. When oxygen looks like nitrogen in a molecule where it has 3 bonds and a lone pair, it's going to have a positive charge. So when you practice enough of these problems, you'll just be able to like just identify that right off the bat. It's just going to have a positive charge because it doesn't have enough electrons localized on the atom to achieve neutrality. They're just shared in between way too many other atoms. And then water we know is neutral. And I mean, if you want to, you can go through and calculate the formal charges, but that one's pretty obvious, I think. And that should be it for this problem. That's pretty much everything it asks you to do. So just keep in mind, that you need to look over just like the big picture thing. Try not to think about all the little things that are going on. Just look over the big picture before you start everything, and just make sure that the net charge before is your plus one charge before matches your charge after. So make sure the things that are supposed to be the same are the same, the things that are supposed to be different are different, and obviously make sure that everything matches up with what you were given in the problem, and you should be able to do well. So good luck. I hope this helped.